I'm Seema and welcome to part 18 of the chapter The Solid State. In this video, I'm going to start the discussion of electrical properties in solids. Solids exhibit electrical property over a range of 27 orders. Electrical conductivity is measured in the units per ohm per meter, and conductivity is usually of solids is usually seen between the range of 10 to the power minus 20 per ohm per meter to 10 to the power positive 7 ohms per ohm per meter, which means if you see the powers to 10 or the order to which 10 has been raised to the power to which order, it goes from minus 20 to plus 7, which is 27 integers, from minus 20 to plus 7. So it shows conductivity in a very wide range, and the range is of 27 orders, that is from 10 to the power minus 20 per ohm per meter to 10 to the power 7 per ohm per meter. Having understood this, that there is a very wide range of conductivity that is shown by solids, let us now understand that solids are divided into three categories based on their conductivity. They are either called conductors, or they are insulators, or they are semiconductors or semiconductors. As the name suggests, conductors would be those that conduct electricity. Insulators would be those that do not conduct electricity. And semiconductors would be those that somewhat conduct a little bit of electricity. So they are, under certain conditions, they would start conducting electricity. So let us understand in terms of these 27 orders, how do we divide these metallic or solid conductors into different categories. Conductors are usually metals. There may be other conductors also, but best are metals whose the conductivities of conductors range from 10 to the power 4 per ohm per meter to 10 to the power 7 per ohm per meter, which is both are positive values, 10,000 and then 10 to the power 7. These are really huge values. So the conductivities of conductors they range between 10 to the power 4 to 10 to the power 7. We know conductivity start at 10 to the power minus 20 and go up to 10 to the power 7. But conductors are only those solids that exhibit a conductivity of 10 to the power, 10 to the power of 4 to 10 to the power of 7. Now metals, which are actually very good conductors of electricity, they usually show conductivities approximately equal to 10 to the power 7 per ohm per meter, which is the highest. If you see in this range, it is the highest. So the best conductors would be metals. So if you have noticed, when I talk of conductors, automatically the word metal comes in your mouth, because usually metals are such good conductors. It doesn't mean that other solids may not be good conductors, but metals, they show conductivity to the range of 10 to the power 7. So they are really good conductors. And out of all metals also, you would see a difference in the conductivities of the metals also. Some metals are better conductors in comparison to other metals. For example, copper, aluminum, they are really good conductors. Silver, gold are very good conductors. And there would be other metals like lead, which would not be a very good conductor. The second category is insulators. So insulators are the opposite of conductors. They do have conductivity, but they do not carry any effective current. They cannot conduct electricity. So they do have and what is the conductivity range? The conductivity range is 10 to the power minus 20 to 10 to the power minus 10, which is both negative values. So They show conductivities between 10 to the power minus 20 to 10 to the power minus 10 per ohm per meter. They are insulators. They do not conduct electricity. Then comes the third category, that is semiconductors. Semiconductors fall between, their conductivity falls between these two, between the conductors and insulators. So these are solids with conductivities in the intermediate range. It falls between these two. It is not between 10 to the power minus 20 to 10 to the power minus 10, and it is not between 10 to the power 4 to 10 to the, it's not as high as this and it's not as low as this. It falls in between. So what is the range of semiconductors? It goes from 10 to the power minus 6 to 10 to the power 4, which means that it does not start at 10 to the power minus, from 10 to the power minus 10, it does not start at 10 to the power minus 9. It starts at 10 to the power minus 6 and it goes up to 10 to the power 4, which means that those four, orders, that is 10 to the power minus 9 to 10 to the power minus 7, 9, 8 and 7. These are the ranges that, or this is the range in which the substance is neither a semiconductor nor is it an insulator. It's not an absolute insulator, but it is not even a semiconductor. Semiconductor also can be used to conduct electricity because they do conduct somewhat electricity. But those four ranges, that is from 10 to the power minus 9 to 10 to the power minus 6, the three values, that is 10 to the power minus 9, minus 8 and minus 7, they are almost as bad as insulators and not as good as even semiconductors. So you could say they are kind of insulators, but we do not put them in the category of insulators. So semiconductors, they fall in the range of 10 to the power minus 6 to 10 to the power 4 per ohm per meter conductivity. Now this is a diagram that explains the conductivity in the case of solids. If you take conductors, for example metals that are very good conductors, as I told you. In the case of metals, there is a special bond that holds the metal atoms together. You've studied about the metallic bonding. What happens in a metal is that you have pure, metals are pure, like they have the metal atoms all together. But then why do the metal atoms stay together? They stay together because they have valence electrons which are loosely bound. And these valence electrons are lost. If the valence electrons are lost, the metal atoms now become ions in a way. They are not completely lost, which means that they do not leave the metal and go away, but they do leave that orbit or orbital in which they are present, and they kind of are loose. They do not move far away to make the remaining metal atom an ion. It's not an ion, but it does have a positive charge. We call it the metallic kernel. Now, the electrons which are released from the valence shell, they are shared, they kind of start floating between different metallic atoms. So, the negative charge which is floating and the positive charge is always attracted to the negative charge. This positive and negative charge, that is the polarity that is created, keeps all the metallic atoms together. Such a bond is known as a metallic bond. Now, if you think in terms of a covalent bond, what happens in a covalent bond? Both atoms contribute one electron. There's an overlap of orbitals and a molecular orbital is formed. If you go to the molecular orbital theory, a molecular orbital is formed instead of atomic orbitals. New orbitals, a redistribution occurs, and new orbitals which are known as molecular orbitals are created. Now the electrons are present in those molecular orbitals and they are shared equally by the two atoms, and therefore the atoms stay together, right? That is a covalent bond. If you try to explain a metallic bond in those terms, what would happen? The different valence electrons, the valence electrons which I told you, the valence electrons are loosely bound, so they tend to move away. Those valence shells, they come closer. There must be an overlap of the valence shells, and some kind of a molecular orbital must be forming. Since there are so many metal atoms, you will not, in a covalent bond there are two atoms and the covalent bond is being formed between the two atoms. Here you have a sea of metal atoms and a sea of electrons which are being shared by all of them. Therefore, the molecular orbitals that are formed are not single orbitals. They are orbitals which are very close to each other in energy. Therefore, they form bands of energy. So these molecular orbitals, they form bands, and these bands are called conduction bands or insulation bands. So these bands that are formed, molecular orbitals, the bands that are formed, if you look at them, the valence shell, which has these loose electrons, forms a kind of a metallic, a molecular orbital, a band in which you have the valence electrons. And if molecular orbitals are being formed, the atoms have higher orbitals also. They have orbitals of higher energy, so those orbitals will also merge to form more bands. But these bands are empty. They do not have electrons in them. So what happens in the case of a metal? The occupied band, that is the valence shell, this is the band, the blue is the partially filled band, because the orbitals they are partially filled, and that is why those electrons, since their octet is not complete, they tend to be loose and they tend to move away. So these molecular orbitals which have the valence electrons, even these molecular orbitals are not completely filled. Since they are not completely filled, the electrons can move about because there are empty spaces in the band itself. And if this band overlaps with a conduction band, with the energy of which is not very high, it is very close. So some of the electrons which are present in the partially filled band, and some electrons can jump up to the empty bands, thereby making those empty conduction bands, which makes them also partially filled, thereby increasing the area in which the electrons can move around. And moving charges is nothing but electricity. So when electrons move around, they conduct electricity. Basically, conduction of electricity takes place by two ways. One is, I told you, movement of charged particles. If electrons move, that results in the conduction of electricity. Or if ions move, that can also result, ions are also charged particles. So when ions move, they also conduct electricity. In the case of metals, it is electrons which conduct electricity. But in the case of electrolytes, where we carry out electrolysis or we have the electrochemical cells, it is the ions which conduct electricity or moving charges. So when we take solid conductors, when we are talking of metals as solid conductors, this is what happens. There is a band of molecular orbitals which are partially filled, and therefore electrons can move and therefore metals can conduct electricity. But if the energy of the conduction band, the empty conduction band, is not very high, then the electrons can easily jump to a higher orbital, that is a higher molecular orbital, which is known as the conduction band, and thus that gives more space for electrons to move around, which improves the conductivity. So this is what happens in the case of conductors. Now if we talk of insulators, in the case of insulators, what happens? There is molecular orbitals are there and the filled bands are there. The band is filled, it is not partially filled. If it was partially filled, there would have been spaces for electrons to move around. But since the orbitals are filled, there is no space for electrons to move around. And the conduction band is empty and its energy is much higher than the filled orbital band. Since the distance, I'm sorry for the disturbance. So I was telling you that the filled band, that is the band that has the electrons or the valence electrons which are present in the molecular orbitals, they are completely filled. So electrons cannot move around. And the empty band is so high in energy that the electrons, even on heating, cannot jump up to the empty band to turn it into a conduction band. So that empty space is available for electrons. That does not happen. Since electrons cannot move, they cannot conduct electricity. And that is why they are known as insulators. The third category is semiconductors. In the case of semiconductors or semiconductors, like you would like to pronounce it, the filled band is down here, and the energy gap between the two is very small. So what happens? That the substance does not conduct electricity normally, but if you heat the substance up, the semiconductor, the electrons may jump up to the empty band, which turns into a conduction band, because now the electrons can move around in that space, and therefore the substance turns into a conductor. So it does not conduct electricity. A semiconductor does not conduct electricity as well as a conductor, but it can conduct electricity when electrons jump up to the conduction band. So the conduction band is empty, there is a small energy gap, therefore with a little jump of electrons, with a little energy, the electrons can jump up to the conduction band and carry out the movement of the current. The moment electrons which are negatively charged move, that they allow the movement of current. They are charged particles which are moving, which is nothing but electricity. So this was the three categories of conductors. Now I will be discussing the first case, that is, how does conduction of electricity take place in metals. I have actually explained it to you already in metals and in insulators. In the next video, I'll be taking up the conduction of electricity in semiconductors. So just reading it out now, because I've already explained this to you. A conductor may conduct electricity through the movement of electrons, as in metals, or ions, so as in electrolytes. When ions move, they can also conduct electricity. That happens in electrolytes. And when electrons move and they conduct electricity, they form, that is, the example of that is metals. Metals conduct electricity both in the solid and the liquid state, or the molten states. The conductivity of a metal depends on the number of electrons, valence electrons, which are available per atom. Now we know metals are those atoms which have 1, 2 or 3 electrons in their outermost shell, right? So how many electrons are available? Like if you have alkali metals, they have only 1 electron. Alkaline earth metals have 2 electrons in their outermost shell. And metals like aluminum, which have 3 electrons in their outermost shell. So the conductivity will depend on how many electrons or how many charge carriers are there. So the more the number of electrons, the more would be the conductivity. So the conductivity depends on the number of valence electrons available per atom of the metal. The atomic orbitals of metal atoms, they form molecular orbitals which are so close in energy to each other so as to form a band. They are so close in energy, you can't tell which electron belongs to which orbital. So they form a proper band. So as to form a band, if this band is partially filled or it overlaps with a higher energy band, then electrons, higher energy unoccupied conduction band, then electrons can flow easily under an applied electric field to the conduction band. And since they can flow easily, metals can conduct electricity. So that is the reason why metals show conductivity. The second part that we are going to discuss is insulators. So what about insulators? Insulators are those where the difference between the filled band and the conduction band is, the energy difference is really high. Therefore, electrons cannot jump up. And since they cannot jump up, even on applying an electric field, they cannot conduct electricity since electrons are not moving. So if the gap between the valence band and the conduction band, that is the next higher unoccupied band, this is known as the conduction band, which is the next higher orbitals band of the next orbitals which are empty. So the difference between the energies of these two, this is increasing energy. So the difference between these energies is really high, due to which electrons cannot jump to it. So if the gap between the valence band and the conduction band, that is the next higher unoccupied band, is large, electrons cannot jump to it. And the substance has very small conductivity. And since how small is the conductivity? Of the range of 10 to the power minus 20 to 10 to the power minus 10. Since the conductivity is so low, they cannot conduct electricity, and hence they are known as insulators. So these were conductors and insulators. In the next video, I'll be discussing semiconductors. So if you wish to watch other videos of this chapter, please click the link that appears on top of the video. And if you found this video helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.